to factor and apply the zero product property to solve polynomial equations. So how about this guy? What do we always do first when we're solving a polynomial equation? Yeah, set it equal to 0, right? We got to put it in standard form. So in this case, we want to make the leading term positive, which it already is on the left side. So we'll just subtract the 48x over to the left side. And that's going to give us 3x to the 5th minus 48x equals 0. Okay, good. First step, always set it equal to 0. Okay, now what? Now we got to factor, right? When we're factoring, what do we always try to do first when we factor? What do we always try to do? It doesn't always work, but we always want to try to do something. Greatest common factor. Yeah, we want to see if we can undistribute a greatest common factor. Okay, can I? Is there a GCF here I could undistribute? Yeah, I could take out a 3x, couldn't I? Okay, what's left behind? Yeah, 3x times what is 3x to the 5th? X to the 4th, right? Minus 3x times 16 is 48x. And that whole thing is equal to 0. Okay, so we're just, at this point, we just have to keep factoring until we can stop, right? We can't stop until each of our factors is at least down to the x squared, to quadratic. It has to be quadratic or smaller. That one is not. That's x to the 4th, this binomial, so we have to keep going. We don't have a choice, right? What can we do? Yeah, now it's a binomial. Think about the strategy here. It's all based on the number of terms in the polynomial. We have a 2-term polynomial factor, the yellow factor. So 2 terms or binomial factor always uses our patterns. We've only got 3 patterns. Difference of squares, difference of cubes, and sum of cubes, right? Sum of squares is not a pattern. So the only one this could fit is difference of squares, right? So let's write that one down. Difference of squares pattern. A squared minus b squared equals what? Good. A minus b times a plus b. And this is like what squared minus what squared? Jordan, this is a difference of squares how? What's being squared in the first term? But what, there you go, x squared squared is x to the 4th, right? So we're going to think of that as x squared squared minus 4 squared. Okay, good. So there's our yellow factor written as a difference of squares. So how is that going to factor? Sam, how's that going to factor? And again, here's our pattern, right? See, so how do I factor that difference of squares, the yellow difference of squares? These are x's? Squared though, right? Because look, my a is an x squared. I get a squared is x squared squared, right? Yes, right? Because that's what's being squared in my difference of squares, right? My a is x squared, okay? Minus, well, you tell me, what's going to happen here then? Minus 4, right? Because 4 is what's being squared. And plus 4. Yeah, there we go, okay? And then out front, we've got that 3x. Okay, now we have an option here. Both of the yellow factors are quadratic. They're down to x squareds. So I don't have to factor anymore, even if I can, but I could choose to if possible. How about this first one? Does that factor any further? So how could I go further with that? Chaz, what could I do there? What pattern's that going to fit? Yeah, good, because that's x squared minus 2 squared, isn't it? Right? Do you guys all get that? Okay, good. So that's 4 we're going to replace with a 2 squared. So that's going to break up into x minus 2 times x plus 2. We've got this 3x that's already done out front. Now, what about the other yellow factor? What about that one? Can I factor that? I can't, because there is no sum of squares pattern, right? So my only choice for this one is I've got to set it equal to 0 and solve that quadratic equation, which is no big deal. We got really good at that in Unit 4. So x squared plus 4 equals 0. How would I solve that? Yeah, I'm just going to isolate the x, aren't I? I can point to a single x, so I can isolate it. So x squared equals minus 4. If I square root both sides, that's going to cancel the squared, isn't it? And so when I square root both sides of an equation, what do I have to include? Plus or minus. And then the square root of negative 4, what's that going to be? 2i, right? Square root of 4 is 2. And the negative inside becomes an I outside, right? So how many, I guess we got 2 solutions there. We got to go back and find the zeros of the other factors though too, right? So what's the value of x that makes x plus 2 equal to 0? Okay, everybody agree? So we get negative 2, x minus 2 is 0 when x is 2. And 3x is 0 when x is 3 times what is 0? 0. There you go. Yeah. And whenever you have a monomial factor like that, some number times the power of x, you're always going to get x equals 0 for the 0 of that, right? So how many should we have gotten for this? 5. How many did we get? Yeah. 1, 2, 3, 4, 5. 1 for the plus, 1 for the minus. Right? Yeah. Yeah, you have to put them all in, and you have to put them all in separately, right? Because so you'd have to break this one into separate them with a comma in Math Excel. Okay, give me 1 to 5. How are we doing? Okay, questions? Okay, probably just take some practice.
Yeah, I'm just kind of watching for now.
Yeah, no, that's fine. That's fine. So I just want to go through one of every type, so when you do the assignment, you got this fresh in your mind. Okay, so there was one. What was the big deal about that one? Well, we did a lot of binomial stuff, didn't we? Right? We had to use a lot of binomial factoring patterns. And we had to, when we found the zeros, we had one factor where we had to solve a quadratic, right? And we solved just by isolating x, no big deal. Okay, how about this one? So it's already equal to 0, isn't it? How many terms in that polynomial? 3. What's our strategy for a 3-term polynomial? Well, I mean, we could use the quadratic formula, but it's easier if we can to just find magic numbers, isn't it? Right? To factor this, to make it look like something quadratic. But in order to make this look like a quadratic trinomial, right now, would you agree the values of a, b, and c in that trinomial are 1, 3, and negative 10, right? Everybody agree? Okay, we need to make this look, though, like 1 times something squared plus 3 times something minus 10 equals 0. It needs to look quadratic. Like in Unit 4, that would have just been x squared plus 3x minus 10 equals 0. In Unit 5, what is it that we could be, what could the pieces be for this quadratic trinomial? Carter, what's going to go in the parentheses there to make this look quadratic? No. Think about like, I need something squared to turn into p to the fourth. P squared, yeah, there you go, right? So I could make this quadratic in pieces of p squared, right? Now that looks quadratic, doesn't it? It looks like something squared plus 3 times something minus 10. That looks like a unit 4 problem, right? Are there magic numbers so we could factor that trinomial? That multiply to negative 10 and add to 3. 5 and negative 2, right? Okay. So then this would split up into the magic numbers plus 5 and minus 2, but what has to go there and there? P squared, yeah. Instead of just being a plain old x, it's going to be whatever this quadratic was in pieces of, which is p squared. And it has to be that way because if I were to expand this out, this times this needs to give me, first times first needs to give me p squared squared. So it just must be p squared times p squared, right? Okay, so now I've factored it enough to where I don't have to factor, and can I even factor any of those? None of them will factor anyway, will they? Right? Because there is no sum of squares pattern, and 2 is not a square. So what do? Yeah, I just need to find the zeros of those two factors. So to find the zeros of something, I just set it equal to 0 and solve. So the first one then just gives me the equation p squared plus 5 equals 0. That's easy to solve. What are the 2 steps to solve that one? Elise, what do I do to isolate the p there? Because that's all I have to do, right? What do I have to do to solve that, to isolate the p? Subtract 5. Now what? Does that make sense? Because I got to get the p by itself, so I have to undo the square, don't I? So I'll square root each side, right? And the square root is going to cancel the squared. So we're going to get p equals, if I square root both sides of an equation, what do I have to include? Plus or minus, good. So I've got my plus or minus sitting out there. Oh, I didn't want to do that. What happened there? Oh my goodness. There we go. Scroll down. There we go. Okay. So equals p equals plus or minus 5i. Good. Because I've got the square root of negative 5. So that's going to give me 5i. So there are 2 solutions. How many should I get total? 4, because it's a 4th degree polynomial equation, right? How about the other 2? Let's look at these guys. What am I going to do there? Add 2 in square root, so I'm just solving the equation p squared minus 2 equals 0. So p squared equals 2. Square root each side. If I square root both sides, what do I have to include? Plus or minus, right? Okay, now giving you a chance to and square root of 2, can that be simplified? No. So I'm just stuck with plus or minus square root of 2, and there's all 4 of my solutions. 2, 4. Give me 1 to 5. Okay, we know how many because when my original polynomial, the degree is 4. So that means we're guaranteed to get 4 complex solutions. Now, if I had a multiplicity bigger than 1, it would count for more than one solution, but I haven't had any like that today. Like if I had, for example, if I had an x squared factor out front, I don't think we've had any. If I had like an x squared factor, like x squared equals 0 when x equals 0, so there's a solution, but it counts as 2 because the x was squared. See what I'm saying? Okay. All right. I'm done. You guys can. All right, last example, and then we'll get out of here. That's a beautiful goat. Okay, here we go. So we're going to solve this one. We got to put everything on one side, get it equal to 0. Put phones away, please. We would choose the left side. Click and close real quick. Take a look. Last one. Well, this is a pretty quick one. We'll go fast. So if we subtract the 98, or add the 98x squared to that side and subtract the 25x, and if I write it in standard form, what am I going to get? So biggest power of x first, what am I going to get? Plus, right, because I got to add it to this side. Okay. Equals 0. Good. Okay, so now we've got a 4-term polynomial. What's our strategy for factoring a 4-term polynomial? I'm going to get 4 answers, true. 4 solutions. Got to factor by grouping, right? Got to break it into 2 pieces. So I'm going to split this thing down the middle. And I got my left group and my right group, right? So in my left group, what do I have to do?
Take the number, you can take like
Greatest common factor of the first group. Very good. Because I couldn't factor anything out at the beginning. I skipped that step. But there was no GCF of the whole thing, right? So now while we're grouping, I've got my GCF of the first group. What can I undistribute from the first group? Actually, 49. Good. 49, and then what power of x? Okay, good. 49x squared. And what's left behind if I do that? Plus 2. There it is, x plus 2. Good. Okay, in the middle, don't forget, in the middle we're going to have our plus sign, right, that separates the groups. And then what has to be true in group 2? X plus 2 has to be the leftover. I got a question for you. Is factoring by grouping going to work here? No, it is, but how do you know? Ah, there you go. The ratio of the first 2 numbers, so 49 divided by 98, right? The first 2 coefficients is 1/2, isn't it? Is that the same as negative 25 divided by negative 50? Ah, it is. Good. So we know it's going to work, right? We did our little test. And 49 over 98 equals negative 25 over negative 50. So we know it's going to work. Okay, so then next step is we know that the binomial factor has to be the same for both groups. So what would have to be factored out to make that happen? Close. Negative 25. There you go. And that works, doesn't it? If I distribute negative 25, I get negative 25x minus 50. So it works like it should. And then the whole thing, remember, is equal to 0. Okay, what's next in factoring by grouping? Anton, what do we do next here? Okay, yeah, we'll undistribute the x plus 2. We're going to undistribute the common factor, which is always going to be the binomial factor. So those go out front. And what's left behind then? Yeah. 49x squared plus negative 25, right? And then if I just clean up that one a little bit, plus and negative is just minus, right? So we've got x plus 2 times 49x squared minus 25 equals 0. Okay, what are my options here? The blue one's done. What about the red one?
7 squared plus 5 and minus 5.
Oh, okay, plus 5 and minus 5. Good. Okay, how'd you get that? No, what was your thinking on it? What was your method? Did you do difference of squares?
Divide it or get it the smallest you can.
Okay, so you factored it then? You broke it into difference of squares? Or did you just solve for x, just isolate x? You got it right.
I saw that, and usually what I do is separate it, so that's what I did.
So you broke it into sum of squares. You said that was 7x squared minus 5 squared. Is that what you did?
Yes.
Okay, that works. Or we could also just set it equal to 0 and isolate the x squared. Either way, it doesn't matter. Okay, let's do this one by difference of squares. That seems to be the choice. So this one, we could split this up into the 49x squared I could write as the quantity 7x squared, right? Minus 25 is 5 squared. And so my difference of squares pattern then is going to give me what? 7x quantity squared minus 5 squared factors into what? Right, but if we're just going to use that pattern, a squared minus b squared, that's going to give us 7x minus 5 times 7x plus 5. Good. And then don't forget the x plus 2 out front. The whole thing is equal to 0. Now, if we just set each factor equal to 0, we got them. What's the 0 of that factor? Negative 2, right? So there's one. How about this one right here? Bailey, if I just set that equal to 0 and solve, I'm going to get x equals divided by 7. There you go. Very good. You're on a roll. How about that one? Boom. Got it. Very good. Okay?
Can I go?
Yeah, go ahead.